So what is ALOHA actually? Okay, ALOHA is a singkatan, okay, a singkatan for Aerial Locations of Hazardous Atmosphere. ALOHA, it's not the Aloha from Hawaii. Okay, it's an aerial location of hazardous atmosphere. Basically, ALOHA is hazard modeling for Cameo software suite. Okay, yeah, I'm recording this lecture. So if you have some difficulties during this class, I will post the actual video after the class in eLearn. Okay. Okay. So this ALOHA software actually, wait. Okay, this ALOHA software actually been designated and developed by DOE, Office of Environmental Safety and Health. Okay, it's a toolbox code for safety analysis. So because it was developed by a government, okay, not our government, US government, okay, so the toolbox is free for all of us. Okay, that's why for this time, okay, for this round, everyone digalakkan, okay, you are allowed to use ALOHA for your plant design. Okay, it's a toolbox for safety analysis. So this is a link where you can download this ALOHA software. Okay, under epa.gov. Okay, so you already heard about ALOHA, and then it said that ALOHA is part of Cameo because actually Cameo is a suite. Okay, it's a suite program. It's a big program, okay, a big computer program. Inside this Cameo, there are few sub-program, okay. One of it is ALOHA, okay. So for your just for your gas dispersion, hazard analysis, and so on, you can just use ALOHA, all right. But if you are interested to find out all the risk assessment, okay, you can download all of this suite, okay. It comes with MARPLOT, chemical, okay, and also Cameo FM is a manager. So for this class, okay, for this class and for your work, for your design work, I encourage you to download MARPLOT and also ALOHA. Okay, later I will show you how you can use this MARPLOT and ALOHA for your plant design. Siapa yang dah install ALOHA dalam dia punya laptop? Hands up. Oh, yes. Right in your chat. Okay. Siapa yang dah install ALOHA? Kalau tak buka pun tak apa. Yang dah install je. Dah prepare to install. Sing Kiong install dah belum? Dia dah lama tanya saya pasal ALOHA. Dia ada link dah. Dah install belum Sing Kiong? Sudah. Okay, very good. Yang lain tak install lagi. Okay, alright. After this you can install. It's very small program. Okay. Tak sampai 200 meg pun. Okay, just install in your laptop. Okay, so download ALOHA and also MARPLOT. Okay, download dua. Okay, you try download both of these, ALOHA and also MARPLOT. Okay, ALOHA software actually is a step. Okay, first is either we want to estimate a potential chemical release. Okay, so for your case, your plant design is you try to estimate or try to find the potential chemical release. Okay, you want to estimate. Okay, but you can also use this to simulate the real case. Okay, the real case study. For project, I think project for EKC 463 last semester, last sidang, okay, they did this project, use a real case study, but using ALOHA software. So they try to find out, is it same with the real plant or not? Okay, the real situation or not? Okay, so you try to estimate the potential of chemical release by using this hazard. Okay, so this is all the hazard that you try to estimate. Okay, is either toxic gas cloud, flammable gas cloud, blaze, jet fires, pool fires, and also VCE. Okay, explosion, vapor explosion, vapor cloud explosion, VCE. So all of these hazard, you can estimate it. Okay, you can try to find what is their consequences. Okay, so ALOHA software try to estimate this hazard by produce threat zone. Okay, by produce threat zone. This is the threat zone. So the output, okay, we say that the output, okay, output from this threat zone, okay, actually can be explained either using ALOHA grid, MARPLOT maps, S-RIS Ash map, Google Earth, and also Google Maps. Okay. Okay, I'm sorry, I don't have point option. Okay. Okay. ArcMap, Google Earth, and also Google Maps. This is how you try to visualize your output from ALOHA. Because actually ALOHA output is only in a text. Okay, as a text. So you try to visualize, okay, this output by using this software. Okay, so that's why I need you to install ALOHA and also MARPLOT, so that you can use MARPLOT to visualize your ALOHA output. Okay, if not, you are just using ALOHA grid. Okay, I will show you what is the difference between ALOHA grid and also MARPLOT maps. Okay, this is the difference between ALOHA grid and MARPLOT. Okay, so which one you see? You think is a ALOHA grid? Left or right? Okay, this is ALOHA grid, a very plain visualization. Okay, very plain visualization. Okay, very good. Okay, thank you, Zaida, Sinkyong, Samuel. Okay, ALOHA grid is on left. It's a very plain. Okay, you just see all the boundaries only. Okay, while for MARPLOT, it is the ALOHA grid on maps. Okay, the ALOHA grid on maps. Okay, so this is a simple maps. As you can see, this is only a simple maps. You can use Google Satellite or Google Maps. Okay, on this plot. Okay, later we will see one of my case study. I try to use ALOHA in Nibon Tebal. Okay, so we will see how it respond. Okay, or what is the output from the study. So actually how ALOHA works. Okay, how you can make ALOHA works. If you know how ALOHA works, then you can try to use it. Okay. there are three big steps in ALOHA. Okay, first is data entry. This is the important part. Okay, this is the important part. In data entry, you enter all the information regarding your incident, the environmental parameters, and so on. Okay, so to minimize the error during your ALOHA estimation, okay, the software already have some default values, okay, because some certain process or some certain incident, there are some parameters that we need to estimate, or it already been given by ALOHA in default values. Okay, if your input values is larger than their margin, or is larger the than it should be, okay, it will be some reminder, okay, some reminder to alert you that that value is not suitable. Okay, so this is for data entry. Then you have your chemical library. Okay, chemical library, it will contain a chemical and physical properties of the chemicals. Okay, in chemical library in ALOHA is more than 1,000 common hazardous chemicals. So I hope that each of chemicals in your plant already inside this chemical library. If not, I think you need some MSDS information, so that you can make some input to the chemical library. Okay, you need to add your chemical to the chemical library. If not, you can directly use all the chemical inside this library. Okay, after you have your data entry and also your library, then it just up to ALOHA calculation. Okay, so there are some give and take for this ALOHA calculation. It based on accuracy and speed. Okay, if you need higher speed or more speed of calculation, then you need to uh, the 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 accurateness of the calculation or estimation will be reduced. Okay, it's vice versa. What do you want? Okay, usually ALOHA will uh, try to give and take. So you got your accuracy and also your speed. Okay, this is a scenario or the input. Okay, required scenario information or inputs. Okay, for your ALOHA, you need your date, time, and location. Okay, for that scenario, it's either past or future. Okay, so it's a basic scenario, means you need to identify where is your location, what is the time of that incident, and when it is happened. Why? Because in some country, the date and time will determine what is the weather during that time. Okay, is it snow and so on. Okay, then in part of chemical, you have your chemical library. Okay, you need your input in chemical library. Then for atmospheric inputs, you need your wind speed, direction, air temperature, and also cloud cover. So remember your EKC 367 atmospheric situation, where you got your gas dispersion. Then this is the source. Okay, the source of that hazard. Okay, the source of the hazard, is it directly from that hazard, or directly from chemicals, or is it leaking in gas pipeline, or some explosion in tank? Okay, you need to identify and make some input to these parameters. Okay, how about the release amount? How many gram? How many volume? What is the volume? Okay, and the dimension of that source. Okay, if you got a leakage in your pipeline, is it a hole? Okay, so how big that hole? Okay, you need to identify that. in your ALOHA. Okay, then the output is the level of concern. Okay, LOC, level of concern. Okay, this EKC 463 this semester already learn about level of concern, how to draw the boundaries for level of concern. Yeah. Should we just only study for one chemical within plant because similar ALOHA could only run? Yes. For ALOHA is only run for one chemical each time. So you need to make maybe a few scenario. Okay, if the one chemical, okay, if you have a multiple component inside your chemical, inside your plant, try to make each of these chemical as a pure. It's a pure chemical because ALOHA could not run for mixture. Okay. So what is your hazard? Is it a toxicity? Okay. Or a thermal radiation? Thermal radiation more on a fire and also explosion. So toxicity is more on gas dispersion. Okay. So this is the step if you want to use ALOHA. First is to enter the information. Okay. After you enter you enter all your information, then you got the display text. What we call as a text summary screen. Okay, this text summary contain all your inputs and also your outputs. Okay, first you enter your information, then the text summary only contain your inputs. Then once the ALOHA calculation already complete, the text summary contain the input and also output. Okay, then from your text summary you can visualize it. Okay, you can visualize it into a diagram or a picture that can help you to estimate the consequence of your hazard. Okay, so the basic or the main step inside is the information. Okay, only information and also visualization. During this, okay, in these two steps is already been done by the software. Okay, for Gigi, if you are interested or if you want to make your uh, chemical that is not listed or when your product of your plant design is not listed in the library, you can introduce or you can modify. Okay, you can add another information for that chemicals so that you can use that chemical in ALOHA. Okay, so ALOHA will determine whether this if there is a gas dispersion, is it light gas or heavy gas. Okay, all right. So this is the output. Okay, this is the output from ALOHA. Okay, you got your output for toxic threat zone. You also got your output for concentration at point. You got your output for thermal radiation threat zone, and also this LOC uh, LOC boundaries. Okay, you got your LOC boundaries. Okay, so we will look on more what is toxic threat zone, concentration endpoint, and thermal radiation point. Okay, once you understand all the theories and what is it, okay, then we can continue with the hands-on. Okay, threat zone. Okay, the previous, okay, the one of the output from ALOHA is a threat zone. Okay, so threat zone usually will contain three area, okay, or three zone. What we call as a red zone, orange zone, yellow, and also dash line. Usually red zone is a highly hazardous, okay, highly hazardous zone. followed by orange and yellow. And we also have a dash line for our boundaries, okay, just to highlight that if the wind change, okay, the area inside the dash line also could be affected. Okay, then trade zone also applied, okay, for all of these hazards. Is either toxicity, flammability, thermal radiation, okay, for most of the fire, flash fire, jet fire, and so on, and also overpressure for VCE. So hazard level usually will exceed the level of concerns. Okay, this trade zone usually can be visualized. Paling mudah sekali, paling mudah untuk kita visualize the display of the output to display the output of ALOHA is using ALOHA grid. Okay, but this output also can be displayed in MARPLOT, ArcGIS, Google Maps, and Google Earth. Okay, nanti kita akan guna MARPLOT in Google Maps. Okay, kita akan tengok. Okay, then your output also have text summary. Okay, since it is a text summary, it's only a text. Okay, so text summary contain text. Okay, display information in text. It contain chemical and physical properties. The source strength of ALOHA means when you say there's a ALOHA means this is the output. Okay, chemical and physical properties is your input, and this is your output inside this inside the text summary. You have your source strength, trade zone, and also trade at a point. Okay, what is the difference between trade zone and a trade at a point? Trade zone is a for zonal. Okay, it's an area. Okay, while trade at a point, you pick one point. For example, you pick hospital. If there is a hospital inside the area, then you pick the hospital. Then the output will be transformed into what is the concentration and so on at that point in the hospital or in school. Okay. All right. Okay, this is trade at a point. Okay, previously kalau trade zone ni zona lah. Okay, zone. But trade at a point, dia dalam ni. Okay, dia dekat satu tempat tu. Dalam satu tempat at a point, okay, for example, point of interest kita is a school or hospital or anything, university. Okay. So at a place of interest ni, okay, it will display as a graph and text. So this is the concentration that occur in that point. Okay. At that point, okay, in 30 minutes, what is the concentration? Okay, for outdoor concentration. And what is the indoor concentration at that time and place? Okay. So this is for point. The previous one is a zonal. Okay, for area. Okay, then we have our source strength. Okay, the output of source strength is a predicted dispersion rate or burn rate for fire. Okay, it will predict what is the dispersion rate for that gas or burn rate for fire. Then the graph of rate, it will contain a graph of rate. Okay, this dispersion rate or burn rate for the first hour or when it's already out or off. Okay, so kalau ada fire, okay, for example jet fire, but it occur only in 35 minutes, so the graph will show only until 35 minutes. But if the, let's say for gas dispersion, maybe it happened in 8 hours, so the graph will show only the first hour. Okay, the first hour only, to show how much is the strength of that dispersion, or maybe jet fire or overpressure of explosion. Okay, but ALOHA also have some limitation. Okay, they also have some limitation due to its assumption. Okay, so ALOHA using Gaussian assumption. Okay, remember your gas dispersion. You have your Gaussian gas dispersion. Okay, that Gaussian assumption have been applied for gas concentration estimation. Okay, so it is affected for very low wind speeds punya condition. Okay, so if your condition is in a very low wind speeds, okay, so your estimation in ALOHA most probably will either over estimate or underestimate. Okay, it also uh, low. Okay, it will come with low accuracy for very stable atmospheric condition. Okay, for example, class E and class F. Okay, for class stability of E and F. Okay, usually your assumption or your estimation of or your prediction of hazard is not 100% accurate. Okay, then there are also some limitation due to concentration patchiness. Okay, patchiness ni macam mana? Okay, is about the assumption that have been done by the software at the early stage of your release. Okay, kalau ada bocor tu at the early part of kebocoran gas itu, okay, akan ada satu assumption, okay, that ALOHA make an assumption that the concentration is average, okay, purata, secara puratanya sama saja. Okay, so another assumption that been made due to concentration patchiness is the assumption that the level of the ground is flat. Okay, so ALOHA assume all the level inside during the dispersion is flat. So what you mean by flat means memang betul-betul rata. So kalau ada liquid, okay, when the liquid spills, dia assume spillage dia sama saja. Dia akan bergerak sampai spillage tu berhenti pada kedudukan yang agak jauh. Okay, but maybe in real case or real plant, okay, maybe tempat tu ada berbukit or ada sedikit lembah. Jadi mungkin spillage tu akan berhenti kat situ. Okay, that's the some limitation, okay, during this hazard. Okay, then the limitation for hazard also come from the effects of hazard. Okay, the effect of hazard. So ALOHA cannot make estimation or cannot produce outputs for byproduct from hazards, the particulates, chemical mixture, wind shift or terrain steering effect, the terrain, and also hazardous fragment. Okay, for example, there is a explosion. Okay, you try to find out what is the consequence of explosion. So during your analysis or during your calculation using ALOHA, ALOHA doesn't take this input, the hazardous fragment, dia punya yang kecil-kecil, yang debris. Okay, from explosion usually have debris, right? But this debris kita tak calculate, okay, or we doesn't include in our calculation. Okay, that's the limitation by using ALOHA. All right. Okay, before we going for ALOHA tutorial, is it okay? Did you understand the background of ALOHA? Just information, that is information, calculation done by ALOHA, and output, what you need. Okay, so you have input. Okay, input usually is what you want. Okay, what you want. Okay, what you want to do. for your plant design. Okay, what you want to do, and then calculation by ALOHA and outputs. How you analyze it. All right. Okay. It's already 11:40. I think 12 o'clock. Dr. Suzy will take charge of your class. All right. Okay. This is some of the example that I did for some small case study. How I make the estimation for gas dispersion, okay, in nibong tebal. So this is the combination using ALOHA and also MARPLOT. Okay, I'm using ALOHA, then import it into MARPLOT, and then I'm using Google satellite. Okay, I'm using Google Maps by using satellite. So this is the output from the analysis. So from this figure, you can know, okay, you can make the estimation where is the area affected by this or by this incident. Okay, well, what type of uh, hazardous effect, okay, in your plant. Okay, so we will look inside this ALOHA. Okay, this is the output, the final output.